The second type of symmetry is y-axis symmetry. If we draw a parabola as such, and we call this x and this y, then we have a point at x comma y that's on the parabola, but it's symmetric to the y-axis, and we'll have a point at the same y coordinate, but this time opposite of x. Right. So any point on a graph that's symmetric with respect to the y-axis will have points xy and the opposite of xy on it. Similarly, we have a test for the equation for y-axis symmetry. The test is that you replace x with minus x, and we'll see that there's no change in the equation. Again, this works because both xy and minus xy satisfy the equation, and so there ought to be no change in the equation because they're both solutions. The third type of symmetry is origin symmetry, or symmetry with respect to the origin. And sometimes this is referred to as rotational symmetry. Let's draw a graph that has rotational symmetry. If there's a point on the graph that has coordinates xy, and we rotate that chunk of the graph 180 degrees, then there will be a corresponding point here at the opposite of x and the opposite of y. Negative x or negative y. So, as you might guess, our test for rotational symmetry will be to replace x with the opposite of x, and at the same time y with the opposite of y, and see if there is no change. If there is no change, your equation will have a graph that has rotational symmetry. Why do we care about symmetry? Well, symmetry can help us graph. If we have an equation with x-axis symmetry, we can find many points on one side of the x-axis, and we'll know that there are corresponding points on the other side of the x-axis. Similarly, for y-axis symmetry, if we find points on one side of the y-axis, that tells us that there are corresponding points on the other side. And for rotational symmetry, if we find some points in one quadrant, we know that in the quadrant diagonal from that, we are going to have corresponding points. So it can really help us with the graph of an equation. There are many videos in your homework and in your book that show examples of testing for symmetry.